lesson is going to focus on vocabulary that you learned last year and rules for simplifying algebraic expressions. It's a lot about the language. In a way, it's similar to Mr. Homan in history class when you do an essay, right? You have to make sure you turn in the margins correct. You got to capitalize the first letter of the sentences and put periods at the end of sentences. Well, this is all the stuff you have to do when you give a mathematical answer, okay? So rules for simplest answer. First, we're going to start out by looking at these 4 vocabulary words: term, expression, constants, and coefficient. They're all words you heard last year from Mrs. Mackay, but let's see how much you remember. I'm going to write an expression up here, all right? So I'm going to write the expression, and you can add this to your note sheet if you have room to write on. 3a squared minus 2b plus 4. All right, so this is an algebraic expression. It has terms and variables in it. A term, you can see here, you have the definition, is basically a number, so the 4. A variable, I don't have any just plain variables there, or a product or quotient of numbers and variables. Right here is a product of numbers and variables, and here's another product of numbers and variables. So each of those are terms. I think the thing that helps students figure out how many terms an expression has the most is this right here. Terms are separated by pluses or minus signs. Okay? So looking at what I wrote here, this expression, this algebraic expression, how many terms does this algebraic expression have? How many terms does it have? Erna?
3.
3. You can look between these signs and see what you got. 1, 2, 3. This is a 3-term expression. Okay? So that's term and expression. Constants are terms that do not contain variables. In my expression I wrote up here, do we have any constants? Any terms without variables? Terms without variables. Anna? The 4. The 4 is a term with no variables in it. It's called the constant. Constant makes sense because it is constantly 4. There's nothing next to it that will change it. No variable that could be changing to different values. So it's just a constant. And then, so now we've hit on term. This has got 3 terms in this expression. The 6 is a constant. Coefficient is the last vocabulary word here. Coefficient of a term is the numerical factor. What does factor? What operation does factor imply in mathematics? Yeah? Multiplication, yes. So a coefficient is a number in a multiplication problem. A number in a multiplication chunk of your problem. When I look at this, do I have any numbers being multiplied by anything? Any numbers being multiplied by anything? Logan?
No.
No? Look at my first term. What do I have there? Yeah. What number do I have in the first term?
3.
3. The numerical portion of it is 3. It's being multiplied by a squared. The 3 is a coefficient. The numerical factor in that term. What about the second term? Is there a coefficient on the second term? What is it? Be careful. They put down their hands if I say be careful. Robbie? What's the numerical factor? The 2. And is this 2 a positive or negative 2 technically? It's negative, right? Because this is being subtracted here. So the numerical portions are the coefficients. Term, expression, constant, coefficient. Is there, it says here, something else for you to remember. When there's no number in front of a variable, the coefficient of 1 is understood. It's kind of like if I say, I have a dog at home. When I say I have a dog, how many dogs do I have? Anna? 1. So when you don't see a number in front of it, it's one of them. Okay? Good thing to keep in mind. Also keep in mind that coefficients might be fractions or decimals as well as integers. Okay, I'm going to write another expression up here and I'm going to ask you some questions about it. Okay? All right. How many terms does this expression have? How many terms do we have here? Caitlin? 4. 4. 1, 2, 3, 4. This is a 4-term expression. Who can tell me a coefficient that appears in that expression? Coefficient. Mikey? 4. The coefficient is just the number, so just tell me 4. 4. Yes. 4 here is a coefficient. Would I be correct to say that the second term doesn't have a coefficient? That the second term does not have a coefficient? Would that be true or not? Yeah?
It would be true because it doesn't have a numerical.
We don't see a numerical factor there. But, how many of them do I have? This one right here? When I don't see the number up front, how many of those things are there? Robbie? How many ABs are there? 1. Yeah, remember when you don't see no number? Don't see no number, that was bad. In front of a variable, the coefficient of 1 is understood. So it would be correct to say the coefficient is 1. So here also, coefficient of 1. When you don't see them, it's those invisible ones, remember? Okay. What are the 2's here? What is this called? It's not on my list, I just assumed we knew it. Luke?
Exponent.
Yeah, an exponent. If you don't know that, make sure you write it down. Okay. Now, the first question in your next test or quiz will have an expression and you have to label these things. You gotta be able to tell me what the coefficient is, what the constant is, what all of those things are. Okay?
Exponent also has a coefficient of
Yep, can't see it, it's 1. Robbie?
So this question 7.5 is a constant.
Yes, good point. The 7.5 is a constant. There's no variable term in it. It's just a constant. All right. So that's the vocabulary. We'll be using it a lot. Don't ignore it. Okay. So let's move on and look at what we do with all of this stuff. All right. Let's move my recorder here. Put it up there. Okay. Okay. We're going to talk more in depth about adding like terms and simplifying now. We've been doing some adding of like terms. You did last year. You did on your homework last night. When you had m plus n plus 1, the m's were like terms, and we said, well, m plus m is 2m, right? So they're going to get more complicated, though. So you got to know that like terms are the same variables raised to the same power. And we can combine like terms together. Last year you didn't have to worry about variable terms raised to powers or complicated ones. They were very straightforward. This year they're going to get a little more interesting. So down here I have a collection of terms, right? I want us to put together like terms. So slide one by the other to put the pairs of like terms together. When you look at all of these terms here in the middle section, right? Who can find a pair of like terms that they could slide next to each other? Or like terms to slide next to each other. How about Caitlin? Come on up. Yeah. Okay, so Caitlin put 5xy and negative 8xy by each other. They're like terms, they both have an x and they both have a y, and they're both to the first power. Can't see the power, it's 1. These are like terms and we could combine them. All right, Logan. Okay, yay, Logan puts 4r squared by r squared. They both have an r raised to the second power. They're like terms. We could add them. All right, we got another set here. How about Will?
Oh, well, first I have a question.
Okay.
About with both r to the second power, if you were to add those, would it be 4r to the fourth power?
No. Good question. We'll talk about that in just a second. Okay. So can you find another pair to put together, and then we'll talk about how we combine them?
Careful.
There we go. All right, 5r and negative 6r are like terms. They both have the variable r to the first power. Now, your note sheet is not magical, right? So you probably ought to write these pairs on the side. This 6 is just hanging out there. It does not have another term that's like it. What is 6 called? I mean, 6 is, Mikey? Constant. Good. We don't have another constant to put with it. All right. So if they're like terms, we can combine them. All right. This xy is really just some unknown number. It's like some unknown unit. Here we have 5 xy's, and here we have negative 8 xy's. What do we have all together? We've got 5 unknown units of the same size and negative 8 unknown units of the same size. What do we have all together, Will?
Negative 3xy?
Negative 3xy. So when we combine like terms, we just add their, what's the number part called? Michael? No, they're coefficient.
And also, since 6 is a constant, could it add with any other group? Could everyone? Like, or could mingle any other group? Like,
It could hang out with them, but it couldn't be combined into one term with them.
but it could still be in the expression.
Yes. Yep. All right. Moving on to 5r plus negative 6r. I've got 5 of these unknown units plus negative 6 of the exact same unknown units, basically. What do I have all together, Robbie? Very good. Negative 1r. All right. So here. Oh, yeah, but what would we call it instead? We wouldn't say negative r. We would say. Remember this from yesterday? Well, the opposite of r, because we don't know if r is positive or negative. Yep, good. All right, 4r squared plus r squared. First of all, what's the coefficient on the second r squared term, Caitlin? 1. So what's 4r squared plus 1r squared, Caitlin? 5r squared. So we're going to be adding all kinds of interesting algebraic terms like this. In order to help you be successful, I want you to keep in mind these 3 steps. First, there's going to be a lot of subtraction in these terms. You will be more successful, I guarantee it, if you change all your subtraction to adding the opposite before you combine like terms. Otherwise, students at this level tend to get their signs wrong. They neglect the fact that some terms are negative. All right, once you change your subtractions to adding the opposites, you're going to combine any terms in the expression that are like terms, just like we practiced up here. When we combine like terms, one more time, what did we actually
Attention,
add?
will Wendy Sue please report to the front office? Wendy Sue to the front office, thank you.
Okay, when we combine like terms, right here, what were we actually adding, Logan?
We were actually adding to 5 plus negative 8.
Yeah, and the 5 and the negative 8 are called the coefficients. So you combine like terms by adding their coefficients. Okay. Good. And then we're going to talk about how you simplify your final answer. That gets into some nitty-gritty details. But let's just start out by combining like terms in these first 2 expressions. Keep it simple right here, right now. Okay, example 1. In this expression, the first thing I should do before I do anything else, because Mrs. Doble said so, is what? Should I do first, Erin?
Change all the subtractions to adding the opposite.
Yes, and I have a subtraction here. I'm going to change it to adding the opposite so I don't lose back that that's negative 12. All right, now I look at my terms and I ask myself, can I add any of these together? Are any of them like terms? Carol?
I was doing less than like 5r plus negative 6r, like, if we, change it to addition, wouldn't that have to be 5r plus 6r?
That's the mistake that kids make, and it's not, because that 6r is being taken away, so it's like it's a negative 6. Remember, subtraction is the same as adding the opposite. So if you change those signs to equivalent addition, you're more likely to catch the fact that that's being taken away or it's negative. Because remember, it was 5r and negative 6r. When I combine those together, it's never going to be 11r, because that 6r is negative.
Oh wait, but there was no subtraction.
Right, I just put the addition in there, so we're adding. Okay, all right, down here. Any like terms in this expression? Any like terms? Mikey?
3x and 8x and 4x. Entire equation.
Yeah, they're all like terms. We can combine them all together. So what's 3x plus 8x? Yeah?
Yeah, 11x.
Plus this negative 12x we have there, we can combine them all, like he says. What's 11x plus negative 12x, Anna? Negative 1x, which we could say as the opposite of x, right? All right, let's look at example 2. How many terms does example 2 have? How many terms, Novacek?
3 and 4.
4. Are you writing this stuff down?
Yeah.
You got it all written down? 4 terms here. Are any of them like terms? Oh, before we do that first, what should we do, Mary? To adding the opposite, equivalent addition. Yes. All right. So now we'll keep track of our signs straight. Any like terms we can combine? Any like terms by Shu?
4x and 2x.
4x and negative 2x, right? All right. When we add 4x and negative 2x, what do we get by Shu?
We get 2x.
2x.
And we can also negative 7y plus y.
What do we get?
Negative 6y.
Good.
But there's an extra y.
What do you mean there's an extra y?
There's 2y.
I know, she just combined it.
Oh, yeah,
Negative
there's not a
7.
1 there.
Right.
Ah.
Right, an invisible 1. Very good. Okay. We're way behind in your class. I think some of you took longer on the homework check. So we are not getting to the next slide of simplifying. But that'll be okay. All right. On your homework tonight, there's a couple notes questions, and then there's some problems like example 1 and example 2 and then review. So worksheet, let me get it to you right now. Okay, next we're going to look at some things that we need to simplify our final answer. Things we have to do in order to simplify our final answer. Okay, sometimes these things are called tweaking. I know Mrs. Kenny next year will say, make sure you tweak your final answers. They're just like mathematical conventions about things you do to present your answer in simplest form. First of all, we use the fewest symbols possible. So, for example, between two variables a times b, we don't want you showing that multiplication symbol. It should just be a, b. Fewest symbols possible. Next, put the variable terms first and constant terms last. So, in an algebraic expression that has a variable term and a constant term, like 6b squared plus 3, we put the variable terms in front and the constant terms last. Within a term, you always should list your variable terms in alphabetical order. So So for example, let's say you see a term or you get to the bottom of your problem and you have something like 3CA. You want to rewrite that as 3AC. You put your variables in alphabetical order in a term. If the variable terms have exponents, you want to put them in descending order from biggest to smallest, that means. So that would look like 3x cubed coming before 10x squared coming before x.
Attention, will the following students please report to the front office?
Okay, so descending again means going down in powers. All right, next, when coefficient of a term is 1, it should be invisible. Just know that, and we're talking about that. Here's something new, and it's going to take us practicing over the next several days. At the end, when you get to your final answer, you're going to change all of adding negatives back to plain subtraction. So something you weren't ready for last year, but you can do now. So for example, if you have 5x plus negative 4, the simplest form answer will be 5x minus 4. And you got to put it back into that form. Right division with the fraction bar. We've been talking about that. Finally, simplify multiplication or division within terms. And I've been talking about this the past couple days. For example, if you have 4 times the product of 6n, you can simplify this multiplication within the term to 24. We'll be working on these for the next few days.